what if I told you there exists a mirror image to the matter we know and interact with every day? Yes, that's right, a mirror image. It sounds like a plot straight out of a science fiction novel, doesn't it? Well, it's not. This is the realm of antimatter, a concept as real as the chair you're sitting on right now. Antimatter is the counterpoint to matter. For every particle of matter, there exists a corresponding antiparticle. But here's the kicker. When matter and antimatter meet, they annihilate each other, disappearing in a burst of pure energy. Imagine that, matter and antimatter, two sides of the same coin, yet when they touch, they vanish, leaving behind nothing but energy. So, does that mean antimatter could be a source of unimaginable energy? Hold that thought. As we delve deeper into the enigma of antimatter, we'll uncover more about its potential and its peril. To understand antimatter, we need to go back, way back, to the Big Bang. This colossal explosion that birthed our universe also gave life to matter and antimatter in seemingly equal amounts. Picture it like a cosmic dance, where every particle of matter had an antimatter partner. But here's the mystery. Today, the universe is overwhelmingly dominated by matter. Now, if you're racking your brains wondering where all the antimatter went, you're not alone. Scientists are puzzled too. They've proposed a theory, known as CP violation, to make sense of this conundrum. This theory suggests that during the Big Bang, a minute fraction more matter was created. This slight imbalance meant that, after matter and antimatter annihilated each other, a small amount of matter was left over, enough to form all the galaxies, stars, and planets we see today. It seems the universe had a slight preference for matter over antimatter. Now you might be wondering, if antimatter has such potential, why don't we use it? Well, the answer lies in its creation and cost. Producing antimatter is no small feat. It requires a colossal amount of energy to generate even the tiniest amount. Think of it like this. To create antimatter, we need to replicate the conditions present at the time of the Big Bang, one of the most energy-intensive events in the history of the universe. That's quite a tall order, don't you think? Now, let's talk about cost. Brace yourselves, because this is going to be hefty. According to NASA, the estimated cost to produce a single gram of positrons, a type of antimatter, is around $62.5 trillion. Yes, you heard that right. Trillion with a T. So, harnessing antimatter is a bit more complicated than flipping a switch. Despite these challenges, the potential of antimatter cannot be ignored. The unique properties of antimatter open the door to a world of possibilities. One of these is in the field of medical imaging. Positron emission tomography, or PET scans, already utilize positrons, the antimatter counterpart of electrons, to create detailed images of the body. In the future, the use of antimatter could revolutionize this field, providing clearer, more precise images that help doctors detect disease earlier and with greater accuracy. Beyond medical applications, the potential of antimatter extends to the final frontier, space travel. The energy produced when matter and antimatter collide is extraordinary. This reaction could be harnessed to fuel spacecraft, potentially enabling us to reach speeds that are currently beyond our reach. Trips to distant galaxies might not be the stuff of science fiction any longer. However, with great potential comes great peril. The same energy that could propel us to the stars could also be weaponized. An antimatter bomb could have devastating consequences, far outstripping the destructive power of any weapon we currently possess. Furthermore, the risk of an antimatter accident cannot be underestimated. A containment failure could lead to a catastrophic explosion. We must tread carefully, ensuring that our understanding and control of antimatter keep pace with our ambition to exploit its potential. While the promise of antimatter is tantalizing, it remains a volatile and mysterious component of our universe. The allure of new technologies and the promise of untapped energy sources must be balanced with consideration for safety and the ethical implications of antimatter use. As we continue to explore and experiment, it is crucial that we approach this potent and enigmatic substance with caution, respect, and a deep sense of responsibility. After all, we're dealing with a force that could power the stars or obliterate them. Thank you for joining us on this journey into the world of antimatter. Remember, the The universe is full of mysteries waiting to be discovered. Stay curious.